computers, and this is Lab 2, Lines of Charge. Hello, my name is Margaret. Lab background. The background of this lab is about finding the electric fields of two pieces of tape and forces with different criteria. This lab includes different skill sets, calculus derivatives, Python programming, as well as the goal of this lab being to calculate the electric field and force between two pieces of charged tape. This lab continues where Lab 1 charged tapes left off. We use the same experiment technique of creating the charged tape, but with a different set of parameters. In this lab, we cannot assume that both the top tape and the bottom tape are point charges when conducting the electric field. Therefore, we must use the line model, which divides the tape into n number of pieces. Then, the electric forces can be calculated using this model. Some measurements for this lab. The length of one piece of tape is 0.195 meters. The mass of one piece of tape is 0.000195 kilograms. The distance between floating tapes is 0.0009 meters, and the gravitational force on the top tape, which is mass times gravity, is 1.91295 e to the negative 3 newtons. Here is a snapshot of the first piece of code for the Glue script. We have our physical constant, we have our change variables, which is the mass of one piece of tape, estimated net charge on one tape, which is 1.2393 e to the negative 8, and then we have the definition to calculate the electric field, which is just copied over right from Lab 0, and the only thing that are changed is the variable names. Next on the left, we have a function that creates a line of n uniform point charges for the given total charge and a mass arranged at equal intervals on the line segment, starting at the start position and extending along the axis. This is essentially creating the spheres that are separating the tape into n number of parts. On the right, we have two different variables, top tape and bottom tape, and both of these variables are using the function line charge to create a representation of the top charge tape, and of the bottom charge tape. It's creating them in scale and size as well as in position and in length. Next, we have code that is representing the arrows, or the electric field in the magnitude for the top tape and the bottom tape. So we have a for loop here, and it's essentially iterating through each piece of the charge tape, which are the spheres that we created before in the last slide. It is initializing the net electric field for the top tape, and then it's creating arrows for each piece of the tape that we created in the previous slide. We're going to iterate through each piece of tape of the charge of the bottom tape, and then we can then calculate the electric field at the location of the top tape due to the bottom tape, and then we can calculate the electric force on the top tape due to the bottom tape. This is where we had to do a little bit of editing for ourselves, and essentially the force on the top tape by the bottom tape was equal to the electric force of the top tape by the bottom tape times the charge of the bottom tape. Arrows were then created to represent the net electric force of the top tape due to the bottom tape, and there were arrows created to represent the net electric force and the gravitational forces. Next, we have code. Here is a picture of what the output of the code looks like. We can see the representation of the top tape in the end pieces as the red spheres, and we can see the bottom tape for the blue spheres. There is a little bit of space there to show the difference of the representation of the hovering and how there is a space between the top tape and the bottom tape. And looking at the calculations, the magnitude of the electric force and the magnitude of the electric field are very similar, which is what we want.